Hi everybody, I'm Bradley from Beckhoff Automation. I'm conscious I sound a little bit Mickey Mousey, but I'm hoping it's just the mic. So I'm just going to start off about Beckhoff, just to lay out some facts and figures. We're a family-run company. We come out of Germany. We are also a global company, and we are a direct sell company, so that means we have a direct relationship with our customers. So what do? We are an IPC-based company that makes automation components. And our portfolio goes from controllers, which are all IPC-based, I/O systems, motion mechatronics, automation. We are a software company, a software house, and a systems company. And you'll see in our stand at the back our new MX system. And we've also introduced Vision. So one of the important things about Beckhoff that I'd like to reinforce is that we make everything in-house in Germany. So we buy components, so we make everything from a board level up. And what that means is consistency of quality and fully automation devices, so they're automation hardened. The other important thing about Beckhoff is that we are an innovation company. And not many people know this, but we are widely accredited to bring in PC automation to the marketplace 40 years ago. It's a global standard now, but 40 years ago, it was a revelation. And what that means is that our life cycles, which is really important if you're an OEM designing machines, is our life cycles are very long. The reason is that we only use industrial components. We don't offload our manufacturing. We are not a share-held company. We are a family-owned company. So that means that we can hold spares, parts, and we can handle obsolescence better than most. So I'm here to talk about OEMs and the challenges of OEMs and doing less with more. And I thought I'd put this slide up just to emphasize something that I've noticed in the last 30 years, is that prototyping and pre-production and production timescale has rapidly reduced. Years ago, that would be a year to 2 years development, and that machine will have a life cycle of maybe 5 years. Nowadays, the life cycle of a machine that an end user might use for making product is a lot shorter. It needs to be flexible. It needs to make more than one product. But for an OEM, that design process from concept to prototype to delivery of first machine has rapidly decreased. And of course, how do you rapidly prototype effectively to production, but reducing your cost and reusing what you've already done and having common components that you can reconfigure? So rather than talk about product, I'm going to talk about technology, and technology that you could implement that will give you that granularity and that flexibility. So one of the first things is how we look at control system, or we being Beckhoff, is the bus system. You need a fast, granular, scalable bus system that can integrate with multiple signal types. Ideally, you don't want it rack bound, and I'll go into that a little bit more later on. The problem with rack bound is you're limited to a rack, and then you have to use rack extensions, which is added cost, and in most cases loss of fidelity. The other important thing we believe is free of infrastructure. When you have a big I/O system or a complicated I/O system or even a small to medium I/O system, do you really want to put switches in? Again, switches, added complication and added cost. So you've got the I/O system. Then I'm going to talk about the controller. You need a controller that is scalable, flexible, and that can handle data. So I'm not going to win any prizes for animation here. So I'm going to go through this. So if you look at a traditional PLC system, now I accept that this is not the case on everybody's system, but I'm broadly taking a broad brush. You've got a PLC, and if you want to integrate motion, sometimes that's a different range of controller or even a separate controller. Then more often than not, you'd have to integrate into third-party bus systems. Again, that's another piece of hardware. More often than not, it's from another vendor, another piece of software, etc., etc. And the problem with that is when you design the machine and you put it out, that's great. But each one of those components in themselves have more often than not a piece of software, but also you have to handle the obsolescence. So if you're buying a mix and match of components, maybe from different vendors, some low-cost vendors in China, etc., etc., you still have to, there comes a point where you have to handle that obsolescence. And what happens is that you end up in a cycle of re-engineering on your standard machine to keep up with the latest components, or changing components, more to the point. As I say, they have an end of life. And then there comes there's lots of industry buzzwords, but then there comes, when you've got a small compact machine, is MQTT PCUA integrating into larger networks. Again, you'd have to use a third-party device in a lot of controllers or a lot of architectures. So, if we chose EtherCAT as a bus system, EtherCAT runs incredibly fast. It's microseconds. You have multiple types that can sit on the same bus system, and that's really important. On the right-hand side that you see is we run EtherCAT down each of our devices, and you can see that you've got communication couplers, high-resolution measurement terminals, zone-proof, explosion-proof terminals, and in the bottom you can see there on machine. That's still EtherCAT, and the fact that we don't use any infrastructure means that our topology is arbitrary. And because of that, we can support, you can see underneath there, we can support third-party bus systems. Now, the importance of EtherCAT. EtherCAT was invented by Beckhoff, by the way. It's a Beckhoff invention that was put out to an independent organisation. What does that mean as an OEM? The amount of devices, you're not tied to Beckhoff. The amount of devices that are available on EtherCAT are second to none, but in any other bus system. So, drive systems, Beckhoff do drives, yeah? But if we don't have a drive that's fit for your application, there's over 500 EtherCAT devices, independent companies. Maybe more importantly is I/O. There's over 1,000 different companies that integrate EtherCAT into their I/O systems. And we're talking about people like Festo, SMC, we're talking about actuator makers, etc. So all of a sudden now, you've got an EtherCAT backbone that is rackless, that can support most industrial field buses, and you have an independent supplier of over 1,000 I/O systems on the one bus system. So you've got a fast bus system that is, every cycle is giving data to your controller. So then you need a controller that can handle that data. So as I mentioned earlier on, Beckhoff are widely accredited to inventing PC-based automation. And what I'm trying to show here is that where it was the realm of a high-end controller a few years ago, now if you think of Raspberry Pis and Arduinos, that small board computer, Now it's mainstream. Yeah. So it makes sense that an architecture, a CPU architecture like a PC, that is used to handling data is your controller. So we've got a fast bus system, a PC-based control system, and then you need software to run it. Now Beckhoff, 40 years ago, came up with a concept of using PC architectures, industrialized PC architecture, I will say, that run software modules. So instead of having different ranges of product that do different things, we have different powers. So our software is the same for a £200 controller up to a £10,000 controller, depending on what you do. You're just buying software runtimes. And the purpose of this presentation really is to talk to you about how we have moved our portfolio from high to mid into the lower section of machine, the small, if I just do this, sorry, into the, 2 to 4 axis simple machine that you don't need masses of technology, but what you do need is something that is scalable and can grow without changing platforms. And this just emphasizes what I'm trying to say. So in other words, I've got a better slide that I'll show you in a minute, but what we're saying here is as PCs get more and more powerful, the more we can do, and we just create runtimes. And this is the only bit of product thing I'm going to show you, but essentially you can see these are the PCs that Beckhoff made. In the bottom left-hand corner, you'll see a range of small Linux-based controllers. And again, I'm going to give you an idea here. I'm not going to win any animation awards for this at all. But essentially, you see an I/O drop, yeah? And all we're doing here is adding software runtimes. So when I said about EtherCAT, our key differentiator is that all our I/O slices and all our I/O devices are true EtherCAT slaves. I'll do that again. So that means that the EtherCAT frame runs through all our devices, which means that our topology is arbitrary. Yeah, we don't use a backplane. And then by adding devices and software runtimes, we can connect. Now, the beauty of PCs means that I've got Windows 10 there. We do support Windows 11. When we talk about Windows, it's really important to understand that we're talking about long-term availability industrial Windows. We're not talking about Windows that you might be using on your laptop. And the reason I talk about that is that they're high security patches. You don't have to connect it to the internet, etc., etc., etc. We've recently onboarded Linux, where we can do Dockers. We can use the Linux ecosystem. And natively, because we're running on a PC architecture, we can communicate upstream without the need of additional hardware. Software runtimes, but not hardware. So, when I talk about scalable platforms, when you are deciding on what you need to use, you don't need to decide on the controller. So your I/O layer can always stay the same, and it can increase. We can do thousands of I/Os on one rack or on one drop. But all you do is you change your controller depending on what you want to control. Now, a £200 controller is not going to run, a kinematic model. So maybe on your smaller controllers, you don't need that functionality, but you can have options where you do. And here's the important thing, is we talk about obsolescence, the next generation. Remember, we are abstract from our I/O layer. we are abstract, our software is abstract from our controllers. So the next generation of Intel, ARM, AMD, whatever it might be, industrial controller, it's a simple recompile. Your whole infrastructure doesn't change behind it. So what we've done is we've used that base technology, EtherCAT, PC control, etc., and embedded it into the MX system. So anything that you develop on our platform is cross-platform compatible. So whether you develop it on an IP20 based I/O system, it's just a simple reconfigure cross-platform to a different system. So all your code base stays the same. We've got an MX system at the back here behind you. And just a really quick case study on a small OEM that were buying, they shipped, I don't know, I think it was about 5 to 10 of these machines a month. The problem they had is that they needed to connect into a bigger ecosystem. So each one of these devices had their own software, had their own, and worked well. Don't get me wrong, worked well. They hit a stumbling block is when they needed to connect into a bigger ecosystem and when they needed granular data for serialization. And believe it or not, it was as simple as that. Just moving to, the product you see there is a screen. It's got a small ARM PC in the back of it with our software runtime, a single cable EtherCAT I/O drop, and then from this PC we can run MQTT OPC UA, and all that machine data from every cycle on your I/O layer is available. What do Beckhoff do? We make automation that sits in all various disciplines. So short and sweet. Any questions? Okay, thank you.